Hello everyone, my name is Cura, who is currently pursuing in various departments for undergraduate in Savita Engineering College. So, based on engineering mechanics and product development, we are being assembled a 3D model which is used to some purposeful uses like in industrializations. It has been named as industry ROM. So, we have just designed that in Fusion 360 software using the layouts and other 3D structures, and we have finally exported into the STL project. So I'm going to first show you the 3D structure of the industrial robot arm. So here's the model. So first we just designed the layout of this model into 2D structure and exported with the 3D software. We can just modify it. We can use extrude, fillet, comments and other modifications of tools free for Intuition 360 software. It is completely free for students. So I'm just going to deassemble it. Like we have just made this into segregate parts and we have finally assembled this into a single component. The first part is like this. These two components used for the industrial arm to just hold it. And this component is just make the frame that these two sectors are being combined in that sector. And the third one is just the body of the power line. And the next one is going to be the third component. And the final component is going to be the base. All these components have been segregated in 2D and finally made into 3D and just assembled here. It has been used further for many uses like assembling products, creating products, using for grab holding larger components, interesting components. So now I'm going to move to the Cura software, which is being used to make this 3D product into 3D printing. So Cura is a software which is just used to make this STL format into the file which is going to be printed further to make this as a 3D component. So scaling is an object which is just used to make the component into resize to whichever size which is being required. And the fan option is used to make this component to move in and around the 3D object printer. We can just move this component to this 3D printer. So just moving in. The green color arrow used to move the component in the horizontal manner. And the blue color component used to move the component in the vertical manner. So we can just adjust it as well. So the red color component used to move to the Z axis of the component. So now I'm going to make this move into that box. So which is being the size of the 3D printer, which is going to be printing the object. And the next one is going to be the scaling. We need to scale the object to the required size. It can be as much big as possible. Uh, the red color object is used for the width and the blue color component is used for the height. And this is the rotate option. The rotate option is used to rotate the component in the degrees as well. It can be rotated in the 360 degrees, even in the based upon the X and Y axis components and using the Z axis as well. So it makes the components to be rotated as soon as possible to just avoid coagulation or printing. Next, we are just going to make this component to fit inside this axis. Just we can also use the down faces like this to see the visuals of which side is being accessible. There are totally 5 faces to see the print, the left side, the right side, and the isometric view. So I'm just now going to use this component to move inside the box. So this one option to move the center and this rotate option to rotate it to make it base fit as. If you are not going to make this component move fit inside this component, we cannot get this slice option because it may throw some error. Like please review settings and check if the models fit inside the build volume are designed to be enabled extruder or not as modified structures. It just says that this object cannot be printed by the 3D printer as it is being excluding the size of the 3D printer size. So we need to resize it to make it small. We just made it small. Now we can see that this object turns to be something like a bluish color. It means that this object is now stable to make 3D printing. It is in the required size and it can fit into the component of the 3D printing. Now I'm just going to make some small adjustments to make it even more firmer. Rotate it, rotate it around Z axis, and I'm going to use it around X axis. Yeah, that's it. Now I'm going to give a slice. So now what would happen is that the 3D printing software will estimate the time upon how much gram it will take and how much time it will take to approximately print this 3D printing of how I just resize it and assemble it in the 3D. So this is the basic project we have just done to the Jensen practical, and that's for today. Yeah.